Hello and welcome to the last lesson of week 9. We're going to distribute radicals today. So, learning target, distribute radicals by multiplying, then adding like terms and expressing in simplest radical form. So you've distributed before, but I don't know if you've distributed with radicals. So here we go. The 5 is not under a radical, so it can only multiply with the stuff outside the radical. So outside goes with outside, inside goes with inside. Kind of a rule of thumb to kind of remember as you do this. So 5 times 3 is 15. Can't do anything with the radical 2. 5 times 7 is 35. Can't do anything with the radical 8. Now I can actually break down square root of 8. I can simplify that. So let's do that. 15 radical 2 is done. 35, 8 breaks down to 4 and 2. But the square root of 4 is 2 with a radical 2 left over. So 35 times 2 is 70, radical 2. Now that I've simplified it, the two terms have the same radicand. So 15 radical 2 plus 70 radical 2 is 85 radical 2. Let's take a look at another one. You can distribute a number inside the radical as well. Inside goes with inside and outside goes with outside. So the square root of 2 doesn't go with 7, it goes with a 6. So it becomes 7 radical 12 plus 10 radical 2. Yes, the square root of 2 times 10 is 10 radical 2. It goes with both pieces. 12 can be broken down though. That's 4 times 3. 10 radical 2 just stays 10 radical 2. The 4 becomes a 2. Square root of 4 becomes 2. And then the square root of 3 stays the square root of 3. 7 times 2 is 14 radical 3 plus 10 radical 2. Don't be tempted to put these together. They cannot go together at this point. Radical 3 cannot combine with radical 2. They're not like terms. So that is my final answer. What happens when you have something squared? A lot of people want to just square both pieces and add the answers. Don't do that. Squared means you're taking whatever's inside the parentheses and you're multiplying it by itself. So I could rewrite this as 6 radical 3 plus 9 times 6 radical 3 plus 9. If you remember from multiplying binomials, which is what these are, we have to FOIL. So 6 radical 3 times 6 radical 3. That's 36. Radical 3 times radical 3 is radical 3 squared, which is just 3. So it's 36 times 3. Then we got to do the outer terms. 6 radical 3 times 9. That's 6 times 9 is 54, radical 3. Then we got to do the inner terms. 9 times 6 is 54, radical 3. And then we got to do the last terms. 9 times 9, 81. Now 54 radical 3 and 54 radical 3, those are like terms. Oh, 36 times 3 is 108. Go ahead and multiply those together. 54 radical 3 plus 54 radical 3 makes 108 radical 3. I'm adding 54 plus 54 plus 81. We're not quite done because 108 and 81 are both numbers. I can put those together to get 189 plus 108 radical 3. That's done because 189 does not have a radical, 108 does, which makes them unlike terms. I cannot put them together. Our last example here, another FOIL problem. So let's do 3 times 3, that's 9. 3 times negative 5 radical 2 is negative 15 radical 2. Inner terms, that's positive 15 radical 2. And then the last terms, kind of confusing here. Make sure you pay attention. 5 and 5, it's 5 and negative 5 really, it's negative 25. And then you gotta do the square root of 2 times the square root of 2, which is the square root of 4, which is 2. Now, the 9, nothing happens. What happens with negative 15 radical 2 and positive 15 radical 2? They cancel. Negative 15 plus 15 is 0. 0 times anything is 0. So that goes away. And there's the 50. Where'd the 50 come from? 25 times 2 is 50. So 9 minus 50 makes negative 41. Yes, this multiplication problem became just a number at the end. The reason for that is because those two binomials were exactly the same except for their signs. We have a fun word for that, and it's conjugates. And we'll talk about that more at a later time. So that concludes this lesson.